Hey guys, welcome back to a new video. So in this video we'll be solving some questions related to arrays and vectors. So without further ado, let's get started. So the first question that we have here is to find largest element in an array. So we'll be given an array of size n and our task is to find the largest element in it. So let's have a look at example. So we have an array that consists 5 elements: 1, 8, 7, 56 and 90, and as the 90 is the maximum element, so our output should be 90. Then we have 1, 2, 0, 3, 2, 4, 5 in our next array, and as 5 is the maximum element, so our output should be 5. So when you are in interview and interview asks you a coding question, and if you know the solution to the question, you should not directly tell the most efficient solution. So you should start with the brute force, then by optimizing it in terms of time and space complexity, you should tell the better approach, and finally to complete your answer by optimizing the better in terms of time and space complexity, you should tell the most efficient solution, that is the optimal one. So here on all the questions we will be solving, so we'll be seeing all the solutions to the question, that is brute, better and optimal. For some of the questions the better might not exist, so we'll see that. So let's get started. So if you are given an array and you have to find the maximum element from it, so what is the brute force that comes to your mind? So the brute force that can come to your mind is to by sorting the array. So if I'm having an array 1, 2, 3, 4 and 5, and I have to find the maximum element from it, so it would be easy for me to find the maximum element if array is sorted. So as you can see, the given array is sorted, so I can definitely find the maximum element, which is 5. So if the array is sorted, so the maximum element would be at index size -1. So let's see the code for this solution. So if you are given an array 2, 3, 1, 4 and 5, and you need to sort it. So if you sort this array, so after sorting, this array would look like 1, 2, 3, 4 and 5. And if you have to find the maximum element, you can directly tell the maximum element by accessing the element at position size -1. So the element at index size -1 would be our maximum element. So what would be the time complexity for this and space complexity? So if you want to sort the array, for that it would be taking us big of n log n if we are using, let's suppose, quick sort. And in terms of space complexity, if I am using the quick sort, so it would be taking of big of 1. I am ignoring the recursive stack space, so the time and space complexity for this solution would be n log n, and the space complexity would be big of 1. Can we optimize this solution? The answer is yes, we can optimize this. The better for this question is not there, so we'll directly jump to the optimal one. So do we really need to sort the array for finding the maximum element? So the answer is no. So we can so if I'm given an array, let's suppose 2, 3, 1, 4 and 5, and I have to find the maximum element, so I can initialize the maximum element to start with as max is equals to the element at index 0, that is 2, and then I'll start iterating the array, and I'll go on iterating through the array, and I'll keep updating the maximum element. So let's see, if let's suppose I'll start iterating from index 1, so here element is 3, I'll ask 3 if you are a greater than maximum element. The 3 says yes, so I'll update the maximum element as 3. Then I'll go to next index, I'll ask 1 if you are maximum element. The 1 says no, so I'll move on to the next element. I'll ask 4, are you a maximum element? 4 will say yes, I am a maximum element, so I'll update the maximum element as a 4. Then I'll go to 5, I'll ask 5, are you a maximum element? The file 5 will say yes, I am a maximum element. So I'll update maximum as a 5. And at the end of iterating the array, you would be having your maximum element, that is 5. So let's see the code for this approach. So to start with, I'll initialize the maximum element as max equals to the element which is at the index 0, and I'll start iterating from index 1. So for int I equals to 1, I should be less than the size of the array, and I'll keep on incrementing the I. So for every index, I'll ask the element at that index, are you greater than maximum element? So if yes, so I'll update the maximum element as the current element, and I'll keep moving on to the iteration. So at the end of the iteration of the array, I'll have my maximum element. So I'll just print the maximum element. So what is the time complexity and space complexity for this approach? So as we are iterating through the array, so it would be big of n, so where n is the size of the array, where n is size of array. And what is space complexity? So as we are not taking any space, so it would be big of 1, as we are using a constant space for the maximum, so it would be big of 1. So let's code it up quickly. Let's start coding. So we'll need an variable for storing the maximum element. So int maximum, so initially it will be equal to the element at index 0. Now we'll start iterating from index 1 throughout the array, and we'll check if our current element, so our current element, if it is greater than our maximum. If it is so, so I'll update the maximum as our current element. So at the end of iteration, our maximum will be storing the maximum element, so I'll return maximum as our answer. So let's try to compile this. Yes, as you can see, our expected output is 90 and our code has given output 90. So let's try submitting this. Yeah, as you can see, it is successfully submitted. So the next question that we have is, we will be given an array of size n, and we have to check whether if it is sorted in non-decreasing order or not. So the first example that we have here is an array of size 5, and the elements in the array are 10, 20, 30, 40, 50. As you can see, all the elements are in the non-decreasing order, so we will be returning a true, that is 1. The array is sorted. The next example that we have is an array of size 6, and the elements are 90, 80, 100, 70, 40 and 30. So as you can see, from first two element, it is evident that the array is not in the non-decreasing order. So you can simply return a 0, that is false, array is not sorted. So how can we solve this question? So the array to be sorted in non-decreasing order, so the all the elements, so the previous element should be less than or equal to the current element. So this condition should be holding throughout the array, so then only the array is sorted in non-decreasing order. So to check this condition, so we can simply iterate from all the arrays. So for int I equals to 1, I should be less than the size of the array, and I'll increment the I, and I'll check if our current element is greater than or equals to the previous element. If it is so, then I'll simply continue and keep on checking another elements in the array, and if this condition is not holding, then there is no need to further check if array is sorted or not, so we'll simply return a false from here only. So when we end up traversing the complete array, so as we have not written false, means the condition is holding throughout the array, so that means the array is sorted in non-decreasing order, so we have to return a true. So that means the array is sorted in non-decreasing order. So that was it about this question. So let's talk about the time and space complexity. So what will be the time complexity for this? So as we are iterating throughout the array, so the time complexity for this would be big of n, and the space complexity would be big of 1, as we are not taking any space, so it would be a constant space complexity. So let's try to code this question. So as we have seen in the dry run, so we'll iterate throughout the array starting from the index 1 till I is less than the size, and we'll check if the previous element of the array, if it is less than or equal to the current element. If it is, then we'll simply continue. If previous element is not less than or equal to the current element, then we'll return the false, stating that our array is not sorted in the non-decreasing order. And at the end of the iteration, when we end up iterating over the array, if we haven't written false yet, so we'll return true. So this will state that our array is sorted in non-decreasing order. So let's try to compile this. So before compiling this, there is one edge case that we need to handle. So what if the size of the array is 1? So any element in the array with size 1 will always be sorted. So we need to manually handle this test case. So if size is 1, then it is always sorted. Then we need to return true. So let's try to compile this. As you can see, it is successfully compiled. So let's try submitting this. Yeah, as you can see, it is successfully passed all test cases. So indeed, we have solved this question.